we're talking about the bioenergy study that we have in place here, and that's a little bit of a misnomer, perhaps, but in the future, in all across the southern region, we may see a lot of different kinds of crops used for cellulosic biomass, and a couple of those crops might be switchgrass. Another one might be high biomass sorghums. Mm-hmm. Those high biomass sorghums are like the ones that are being worked on in the sorghum program at College Station. We've got a study here looking at how nitrogen will fit into the equation of producing those high biomass forage sorghums, and also how plant diversity and using something other than just a monoculture of a cropping system will work, and how that fits together with nitrogen fertilization and with wildlife. I mean, that's all kind of a big concern. Mm-hmm. Even if we don't really know how profitable these systems are going to be. We don't know exactly how they're going to impact our environment. We know we don't want to allow a lot of we don't want nitrogen pollution in our streams and our rivers. Mm-hmm. So we want to be able to produce these crops in a way that's sustainable, and we want to be good stewards of the environment and of our resources with nitrogen. We want to be able to, we don't really want to have a monoculture of a crop where we have no wildlife that interacts with that crop. So we don't want to plant something that the deer will just eat and we'll have no crop. We don't want that either. But so we want to balance. We want to balance between being able to have a good natural environment for these crops. We want to do it in a sustainable way so that it's profitable and that it's friendly to the environment. In some cases, when we go into our and we're changing this, but in some cases we've looked at our systems of production with blinders on, because we see we have a good crop, and we can take an example. A good crop that we have that we use here a lot is our warm season grasses, like our Coastal Bermuda and Tifton 85, and those plants in these soils, they respond well to nitrogen fertilization, and that's great. We can take those crops and we can apply fertilizer nitrogen, and they can be very productive and very profitable and economical to use. However, in situations where that nitrogen fertilizer becomes very expensive, then we're forced to look at other alternatives, and maybe even maybe in some cases it may be even unavailable if we have the nitrogen fertilizer is produced from fossil fuels, usually from natural gas, and so that kind of thing is tied to our energy policies and our just our dependence on fossil fuels. There's a lot we don't know about the fate of the nitrogen in these systems, and what we want to do is we want to be able to be very, very efficient in how we use nitrogen as a nutrient. We want to, if we have to apply nitrogen through nitrogen fertilizer, we want to make sure that we use that the crop plant that we're applying it for uses it very efficiently. And we also want to be able to match that or complement the use of the fertilizer nitrogen with the nitrogen that we're gaining from the legumes. And as you can see, this makes it a complicated arrangement, because we have nitrogen coming in possibly from the cool season plants like crimson clover. We have nitrogen coming in from the warm season plants like cowpea. And then we have nitrogen that we may be applying or not applying in the summer for the growth of the high biomass sorghum. So we need to know things we need to know more about. We need to know how the applied nitrogen complements the legume nitrogen. We need to know the what happens to this nitrogen. What happens if we have dry conditions? What happens if we have extra rainfall? Which system provides us a more sustainable year after year high production of these crop plants? Can we use? There's just a lot of questions.